Welcome back. Today we have a U2000 that has seen better days, and I'll explain that in a moment. But all of these chassis that you see me work on that have these little white tags here are all from the same person, so there's going to be a lot of them here in the near future. A couple of them actually don't have a tag, so they'll be a bit unknown, but a majority of them are going to have this white tag identifying it here. If we look at this one here, this one says Tekken. Works obvious with coil, which you can see the width coil here has seen better days, and we'll fix that here momentarily. But whenever we get these chassis, you always want to give them a good look over. Most all these chassis were super filthy, so I went through and washed them all previously before I mean they've been sitting here for a couple of days. So all these ones with the tag you'll see that I work on here shortly are all part of the same lot. And they were all super filthy, super dirty, and I washed them all, let them sit for a while, and now it's ready to start working on it. So if we give this one a quick examination, we can see that it's missing the remote board, which isn't a big deal. I have some, but you know, I need to make a note here when I send this back, a big note that says, make sure you hook up remote board because it'll destroy it. If you ever hook these up without the remote board hooked up, it will zap it out. So sometimes you can get very lucky and, oh, I forgot the remote board, turn it back off and get lucky, but if you leave it on for any length of time, you're going to damage vertical IC and who knows what else. But anyway, so apparently this works, but I don't think so. And I say that because we'll inspect it and I'll show you. But for the actual neck board, it looks very good. It's obvious that no one's ever removed it because the glue is still intact on the G2 wire here. No one's ever taken that off. All of our transistors here are nice and evenly spaced, so are our resistors. They're not loose. That's secure, that's secure, that's secure. So our solder joints are in good shape. It's going to be hard to see, but you know, I have to do reflow anyway, so let me just cut this off. Cut this off here. Come on. Come and knock on our door. We've been waiting for you. Yep, just like I thought. We've got some good intact traces and solder joints, so that's nice to work with for once. But what's weird is somebody has installed this connector on here. I have no idea what this is for, why anybody would do this, and it's hooked to the 15 volts. If we look here, there is a 15 volt, plus 15 volt, and if we look at the trace, it runs right to that first pin there before the key, which happens to be our 15 volts. So someone's got a header thing soldered on here to the 15 volt supply, and the ground trace here goes to the negative. So what this is for, why it's here, I cannot say. I would have no idea, but I'm not going to remove it because it must be serving some type of purpose, and I don't know if it, I don't know. All I can do is fix this. And if they get it back and hook it up and it goes out again, then I gotta wonder what it is that they're doing here. But anyway, so let's go ahead and keep looking. Our neck board looks good. Someone has replaced, is that R, which resistor is that? That is R 500. This resistor here, R500, someone's replaced that with a ceramic one. And why they would do that, I can't say. 5 watts, 2.2 ohms. Last I recall, does that read 2.2? I don't know. I don't think so. Let's see here real quick. This is obviously a parts neck board. Parts neck board that I have sitting around here. Yeah, well, look at that. I gotta get a good measurement here, sorry. 0.5. Let's take that out of circuit here. Oh, well, maybe it is. Look at that. Out of circuit, it's 4.2, 4.1, 4.0. Well, interesting. They put this ceramic one in here for some reason. well, having a 1.4 ohm difference, not really going to affect anything. Not in this case. Interesting. So we found that as well. Otherwise, neck board looks pretty good. I'm going to disconnect it so we can get it up out of our way and we're not encumbered by it. We're going to flip up our connector here. Come on. There we go. Get our focus wire out of there. Disconnect our G2 for the first time, which is going to be tough with this glue they put on here. We're going to try and help it along. There we go. G2 wire's off. Neck board connector on the main board is off. Now we can remove our our neck board and set it aside. Just looking at this, it's got some more kind of jury-rigging type of stuff here with this power connector. There's just 2 sockets sticking in the power. I mean, if that works, that works. And somebody has moved the wire from the ground point, the middle one's always ground, over to the, so some odd stuff's going on here, but I'll leave it all in the way they had it because that was working for them. But if we look here closer, I know what I was saying. I don't think it's marked as working, but I don't think that it is because somebody has been doing some trying to adjust B plus and the shutoff pot. Now I say that because if we look at the B plus pot, somebody obviously tried to adjust it because they busted off the cap trying to get the glue loose. Now it doesn't appear they broke the pot, but they've busted the top part off. Now in all theory it should still work because it's not damaged, but I don't know. So we're going to have to replace the B plus pot. And if we look at the shutdown pot, somebody has cracked the glue loose on the shutdown pot, and I'm able to move it. If we look here, I can see how I can move it. So somebody has broken the glue loose on the shutdown pot, and I can turn that one too. There, see, I can move the shutdown pot. So someone has been doing some type of tampering with this to try and get it to either adjust or work or done something. So I'm skeptical on it actually operating. So I'm not even really going to worry about trying to turn it on. We're just going to do finish our inspection and do our testing, and if it works, it works. If I find nothing wrong out of the ordinary that jumps out, doesn't jump out off the screen at me, whatever, off the page, then we'll just kind of continue on and proceed as if it does work. But we're going to have to see if I can set this back to where it was. It looks like it was roughly right there. Yeah, that's probably about accurate. Now the B plus pot, I guess we can measure it and see if it reads properly. I don't know what it should read as far as ohms when it's sitting there. I think it's a 2K. Is it a 1K? It's either a 1K or 2K. I can't recall at the moment. Let's just read it and see what we get. So if we just go to ohms and read it, we get, it's a 1K pot. So it's 329. I think this one's a direct short. Yeah, so the pot's not broken. So I guess what we can do is finish our inspection and fix our coil here. Actually, you know what? Let's get rid of this since there's no remote board and this is just kind of in our way. Get rid of that. So with the linearity coil is also broken. The magnet's fallen out. So this needs glued back on. Very common in almost all of them during shipping anyway. So we have to fix our linearity coil. Our horizontal coil is busted. So it's just a coil of wire, but we should be able to kind of re-spool it on here and glue it back in place. It may not look good, but we can probably fix that too. So this needs fixed, this needs fixed. The B plus pot needs replaced. Otherwise it seems okay. I don't see any bulging caps. They're all absolutely original caps. None of them have been replaced. So, yep. So let's see if we can, I guess what we can do is I'll try and fix these. I'll glue this in place, and I'll have to hold them in place. So let me get that done. I'll fix these, glue them in place, and I'll come right back. Alright, so I got that done. The Linearity coil is super glued in place and it's nice and secure. I can lift the whole chassis with it. The horizontal width coil I was not able to use super glue because I didn't even try, because the plastic shaft that the coil actually goes around and sits over is broken and missing. So there wasn't anything to really glue down. So I had to use some hot glue. I just lifted it, moved it over, hot glued the bottom of the plate there, and shoved this back down and held it. And now it's nice and secure as well. So our horizontal coil is secure. Our vertical coil, linearity coil, is secure. So now we're ready to move on. And I also noticed something while waiting for this to dry, holding it, waiting for it to dry. I noticed two things. One is that this resistor by the B+ pot, I didn't notice until just now. It's all damaged and it will most likely be fine. The coating is gone. The resistor itself isn't damaged, it's just the coating they paint on the outside for heat dissipation and protection is gone. So I'm probably going to replace this resistor, because just the way that it's sitting here like this, when I change out the B+ pot, we'll change that resistor out. But I also mentioned how none of the caps are replaced and they're all original, and that's true. I double verified just from the brand and everything, but this one's been replaced. So I gotta wonder if this has had in the past or currently has vertical collapse issues or vertical issues, because this cap has been replaced and this is one of the main caps in the vertical circuit, vertical deflection circuit. Now, something else that's interesting though is that on the 7400, 7500 and the 5000, I am 100% positive that it's a 35 volt 1500 microfarad. But if we look at this one, it's only 1000 microfarad. If you can see here, let's try and get some light. Maybe, there we go. If we look here, you can see that it's only 50 volt, well, it's 50 volt, it should be 35, but 1000. So I don't know if the U2000 uses a 1000 versus 1500 like the rest. I actually have a couple of U2000s. I'll go check it out. But I could be wrong, but I'm fairly certain it's supposed to be a 1500, but it may be, if memory serves, I think maybe 1000 might be correct, but ultimately we'll find out. I have a cap kit, we'll get this done. But I wanted to point that out, is that this resistor is all damaged and broken up, and we have a capacitor replaced in the vertical deflection circuit. But everything else is absolutely original. Then we have the common things like this polycap bent over, resistors out of shape. But otherwise not too bad. I have not even turned it over yet to look at the back. We have, I don't know if that's the original resistor there or not. Interesting. I'm just talking to myself on right here, this resistor underneath R823. It just seems kind of big for its position there. I wonder if anyone's replaced it. I think someone's replaced this resistor here, this one under here. Like I say, I have not turned this over, but the cleaning looked very good. We got the cleaning done. It's a nice, good looking chassis now. So let's go ahead and turn this over and see if it's a horror show on the bottom. So here we go. Oh, not too bad. And yeah, someone has absolutely replaced that. Let me remove this here. And it looked odd. This resistor right here is too big for what it should be. This one underneath R823. And if we look here, yes, somebody has definitely replaced it. This one right here. So someone's done some work there. Not sure why that is like that. We'll have to inspect further. But we've got some bad, crappy looking solder joints on the power connector. Zoom back out here and give it a good look over. We've got what looks like someone has replaced R760. This is a resistor here for the horizontal deflection circuit. If this goes out, you can take the HOT out. And someone has done some work on that. We can see that as evidenced by this here. Right there. Someone's done some work right there with that. It goes across here. And, you know, solder joints like this look bad. Not sure what's going on there. We've got some trace damage there. Evidence of reflow on our vertical IC. So just as I suspected, this cap appears to have been changed, so maybe I'm wrong. I don't know, it's that cap right there. 50 volt 100 is what that should be. Maybe that's been replaced as well. Could be. Looks like it might have been, or at least reflowed. This capacitor here is the one that was replaced, and unlike this one, it looks like it's not. Maybe it hasn't been replaced, I don't know, but the glue, as you can see here, is not on the cap. So that's absolutely been replaced, but it's just odd that you'd have a nice clean joint here. I lost it right there, and then this one's still got flux all over it, so very odd. We've got someone's been doing something here with Q710. This guy right here, the width transistor, because if we turn this over and look, here it is. We got some trace damage right there. So I don't understand what's going on with that. It doesn't look like anybody removed it. It looks like it's still in there from the factory. So I don't understand how this could possibly happen unless somebody dug something in there and broke it open, but that's very odd. It could be as a result of this damage here, could be tied in with whatever caused this damage right there. So let's zoom back out and see if anything else we notice right offhand. I'm not used to seeing this capacitor across here. Not sure what that is. That could be a factory mod. I'm not used to seeing that. You know, I work on a lot more 74, 75, 5000s than 2000s, so this could be factory, but obviously it serves a purpose, so I'm not going to remove it. But it's tied to one of the legs of our HOT. You see our HOT is right here, and it's tied to one of the legs of our HOT. I think that's the base. And it's going to what looks like our horizontal coil. This whole stretch of pins here is our horizontal coil, so it's going from the HOT to the coil. Now I'm not sure why. Like I say, it doesn't seem familiar, but it could be. So just looking at the rest of this, header pins for remote board, neck board. So all I really see is the damage here, the lifted pad on the horizontal width transistor. This odd cap, maybe it's factory, I can't say, I'll find out. R104 solder is good. Yeah, alright, so I don't see anything I need to fix. There's nothing here I see that I need to fix or repair before we attempt to power it. Q703 appears to be good. Yeah, I don't see anything that I need to repair or attempt to fix prior to power application. So I guess what we can do is I will replace the B+ pot, and I will replace this resistor, and then we will do our light bulb test. I don't see any bulging caps. I'll change these parts out. We'll do our light bulb test. We'll see if that works. We'll get our B+ set to roughly 125, which should equate to 117 when it's powering on a tube, 125 with the light bulb, and then like I say, that should equate with the larger load on the system with the tube hooked up to 117. And assuming that it turns on, we'll see if we can get a decent image and how it looks, and we'll get our shutdown pot adjusted, and then we'll do a cap kit and a reflow, and then see if it looks any better afterward. After doing the cap kit and the reflow, maybe it'll look the same, depends on how it looks prior. We'll see what happens. I guess what we should do is test some components real quick just to make sure we're not going to have any problems and we don't waste our time, because we have had prior work done to this. So I think what I should do here, I didn't plan on it. I wanted to kind of make this a quick video, but I guess what we can do, since it has had work done prior, let's test R104, make sure it's 10K to 13K. 9.6 is fine. So that should mean that we have a power supply here, at least anyway, nothing is shorted or bad on. Well, I don't know if the switch mode power supply chip's any good. When you test this resistor, if it's within spec, it either means, well, if it's not within spec, it usually means that either the resistor is bad, and you would need to take it out of circuit and measure it. If it checks good out of circuit, then something is bad here, influencing it. If this reads good in circuit, you can usually bet that all of this stuff here is good. That's all I'm saying. In my experience, when this reads bad and it reads good out of circuit, bad in circuit, there's something here bad. If it reads good in circuit, then most of this is usually good. That's just my experience. It's just a quick and easy test to see if you got something possibly wrong in the power supply section before you turn it on or do your light bulb test. R303, I want to make sure we don't have collapse issues. 2 ohms is good. D302 should be good. Come on. Okay, D302 is good. R760 and R765. I think R760 should be 400 and 440, somewhere around 440. 467, close enough. 765, I think, is supposed to be 33K. 32.54 is good. D603 should only read one direction. That's the correct direction. Does it read backwards? It does not, so our vertical IC is not shorted. I think, let's test our HOT, make sure HOT is good. If that tests good, then we're just going to do our, well, let's just check it first. Hold on. HOT, we're still in diode mode. Oh, crap. Shit. HOT is shorted. Gosh darn it. What does this resistor read here? 3.3. Oh, I guess that's correct. Is the trace good? It goes to here. Yeah, trace is good. Gosh darn it. Well, I guess I'm glad I checked it. I don't know why it would be shorted. Let's test that inductor there. Is this inductor good? It's a bit crispy, yeah. Okay. Well, HOT is out, but we know that 765 and 760 are good, so it's not a cause. That's not the cause. It's possible someone tried to power this up with the remote board missing, and that could have done it for sure. Absolutely. Let's test D707. This diode in here. But the HOT shorted in circuit. This all could read shorted. That one's okay. That one's okay. Well, I stand corrected on that. Those all read okay. Then there's a diode in here I want to get to. It's hard to get to. Yeah, see that with the HOT shorted, I got to take it out of circuit. Well, gosh darn it. Okay, well, let me, I'll change out the B plus resistor, or I'm sorry, this resistor by the B plus pot, change the B plus pot out, the resistor, the HOT, and then we'll come back and do a bit more testing and see what we get. All right, so before we really kind of go on, I've got the B plus pot removed, I've got that damaged resistor removed, and I got the HOT removed. With the HOT out, that diode that was reading shorted, it's down in here. I don't know if you can even see it. It's that diode right down inside there. If we check it now, it checks good. So that's why it's important to test components out of circuit. So if we test our HOT, shorted. So let's go ahead. I'll grab a new B plus pot, another resistor, new HOT, get that all put in here, and then we will do our light bulb test. And if that passes and we get everything set properly, we'll just turn it on and see what happens. But my suspicions were correct with this. It's marked as works, but obvious with coil issue. My suspicions were correct based off how it looked. That I did not think that it actually was functional. And like I said, we checked everything here, and it all seemed okay. We didn't test Q703. Probably should have done that now that I think about it. Q703 again is this guy, and it should be, I think, actually we would have found with the HOT shorted in circuit, it reads our voltage drop to one leg, and I think like 0.6. We get voltage drop on both legs when the HOT is shorted. When the HOT is not shorted, you get voltage drop on one leg, and I think 0.9 or 1.0 on the other leg. So let's just go to this leg here. There's our voltage drop. Now this leg should be around 1.0. 1.2, close enough. Now if the HOT in circuit is shorted, this is a good test if you don't get to that point yet, because if you read the HOT, if the HOT is shorted in circuit, you'll read 0.6 on this leg and 0.6 on the other leg. So that will tell you that you've got a shorted HOT. It's a good indication that there's something wrong on the horizontal circuit when you read your 0.6 voltage drop to both sides of Q703. But as you can see, with the shorted HOT out, we're reading our 1.2. So that should be a good sign there. So let's get these. We can check our poly caps, but I don't think they're going to read shorted. Yeah, that's fine. That's fine. These two poly caps here, because these can, if these are shorted, they can take the HOT out. I'm fairly confident here that we either have a capacitor problem or they tried to power it on without a remote board hooked up on the other end of the chassis. So I can't say, but everything else appears to be okay. All of our initial testing for things that would take the HOT out have been tested. R765, 760 are okay. Our poly caps, our diodes over here, all that stuff checks good. So the HOT, it may have gone out because of the missing remote board, but I have one, so no big deal there. So yeah, and interesting, the U2000 and the U5000 use the same remote board, and the 7400, 7500 use the same remote board. You cannot interchange those. You cannot use a 2000 remote board on a 7475 and vice versa. You cannot use a 7475 remote board on a 2000 5000 because of the H hold pot. The horizontal hold pot on the 2000 5000 is on the remote board. The horizontal hold pot on the 7475 is on the chassis. It's right here, give or take. So you cannot use those in exchange of each other. If you have a 2000 5000, you cannot use a 7475 remote board. Oh, someone's at my front door. How about that? You cannot use that to exchange each other, or you will damage the chassis. So let me go see who that is real quick. It's just a delivery of some other stuff. All right, so I think we are ready to go. Let's get a new HOT in there and the other parts here, and we'll see how this turns out. Okay, so we've got HOT replaced, B plus pot replaced, and I think it was R111 replaced. So we got the new B plus pot installed, and it's set to 330 ohms, same reading this one was set to. We got the new R11 installed. It reads the same as the one that got taken out. There's still some glue on it. There's some glue on it from the chassis I rubbed it from, but it's much more intact. And our new HOT is installed. It's a 3688 versus the 3686, which is the same thing, but a bit more modern. And let's go ahead and test it in the circuit, make sure it reads good. And 0.5 and 0.5, so we're good there. So I think we're ready to test it. Normally you see me test the switch mode power supply chip, but I think I have plenty of videos on that already. I think what I'm gonna actually do is just start doing the light bulb test from now on. If the light bulb test works, then the switch mode power supply chip is functional. So we don't really gotta worry about what it reads, what it should read, what it doesn't read, what the correct readings are. The easiest way to do it is just do the light bulb test, which you'll see here shortly, if you haven't seen it yet. The easiest way is just do the light bulb test. If the light bulb lights up, the power supply section is A-okay. If it doesn't light up, then you can worry about this chip being bad. So I'll just start doing that from now on. So now that we've got everything tested and in theory should work, if the HOT goes right out again, then we'll kind of worry about that from that point. But we've tested all the normal components that you would want to test in the situation, I guess except for the switch mode power supply chip, but we'll consider the light bulb test here shortly part of that testing. So we'll go ahead and do that, and then we will see what we get. So let's get that set up here. I'm gonna need 3, 1, get off of there, 2, and that's 3. All right. So this will hold, where's our meter here? This will hold our meter on ground. Okay. And this will hold, well, this will hold this. But then we need to get, what is it, R1, this jumper, W156. I almost forgot to explain how this works. On the U2000, there's a jumper here. You gotta unsolder this jumper out of the terminal here. Let's get that done first. I almost forgot to do that. I'm a dummy here. Let's just get this out of here. That doesn't want to come out of there. It's hooked in there, that's why. There we go, got it. Okay. Okay, back to where we were here. So we have the jumper removed from the circuit. As you can see right here, it is out of the circuit. That will remove, what that'll do is that will keep the power supply section from energizing the rest of the chassis. This is all isolated now from just this point by taking that jumper out of there. So if we clip my ground back on here that I lost, that's for the negative for our meter. The positive, you'll want to hook to this jumper. You'll also want to hook this other one to the jumper. And what we'll do is we'll go to volts DC. We should read around 170 or so if we're successful on our adjustment. And if this works, it should be around 170. Then we put a load on it, it should be around 125. So I get a new light bulb here, hang on. I damaged my previous one. So with a 23 watt bulb, we're hoping this is going to be around 125. So the first thing to do is turn it on, plug it in, and turn it on and verify you actually get around 170. So let's go ahead and just turn it on. Make sure nothing is touching. We've got our ground for our meter and our positive hooked up. Let's go out a bit. Okay, so yeah, our meter is hooked up. On our positive, go onto our jumper. And then we have a ground hooked up. So our meter is in circuit. And we have this jumper here is coming off of the same B plus output from the power supply. We will touch this to the middle of our bulb. And then we'll touch our ground to the heatsink frame. So basically we'll touch the ground and touch this and it'll zap, boop, light turn on. We should read around 170. So let's go ahead and turn on our power to the chassis. Here we go, 1, 2, 3. Okay, chassis is on. And you see we have 100 and, what am I saying? Whoa, 190? Holy shit, that's way too high. But does this work? Yes, it does. 136, that is way too high. But we can adjust that. So we know that our power supply section is now functional because our light bulb lights up. So there's no reason to go through and test anything in the power supply section because it powers up. It's just a much cheaper, well, it is cheaper, I guess. It's a much easier and quicker way than going through and testing by just doing the light bulb test. So that's how you do that. So now we know that we're way too high. So if we were to, now we're set up to adjust our B plus. So if we actually go to, if we turn our, we're going to turn this back on. 1, 2, 3. It's back on. As you can see, this is jumping up. Now I turn this down to where it gets to about 170 is what I want. It's not letting me adjust it because there's no load on it. It's going to be tough to do this with one hand here. I should be able to adjust that. So if we do this again, 136. So I think what we have that's going on here is that in the meantime I have hooked up this other jumper here to the ground of the light bulb. That way I can turn this system on and just touch the light bulb and then adjust my B+ accordingly. So ideally we want this to read around 125, like I said. So if we turn our meter back on and we turn this on, 1, 2, 3, we're climbing back up to our 190 again. And if I just touch this to here, there's our 133. Now I should be able under load to adjust this B+ down to around 125. Bingo. 125. We'll leave it right there. Perfect. So now we should be around 170. Stop! Stop! 125? Hell. I guess this voltage here, when it's not under load, doesn't necessarily equate to a problem. You really want it to be adjusted properly under load. So if we actually touch our bulb, there's our 125. That's perfect. Absolutely perfect, because somewhere, this should end up somewhere around 117 when we actually have this on a tube running. It should end up somewhere around 117. So what this means is that our B+ generation for our power supply section is A-OK. That's a much easier and quicker way to test it than doing all the individual testing. So we test our R104, if that tests good, do the light bulb test, that's all you really need to worry about. So now we can actually dissipate our voltage here. If we were to take, let's say for instance, our lead here that was touching our bulb, you can see we still have stored voltage in the B+ rail. If I just go like this, it goes right down to 0. Immediate discharge. So now we can handle it safely without getting zapped by something, stored energy in a capacitor or something. So yeah, I think we're ready. Let's go ahead and just get it hooked up to a tube and power it on, see if it works, see if the HOT goes out again, see if something explodes. But we should be good because there's no bulging caps. I don't see anything immediately like, oh, that needs fixed immediately type of stuff. We got that resistor replaced. We know our B+ is set properly. We'll have to adjust our shutdown pot if it does power up. It should be 0.1. I'll show you how to do that. That's no big deal. So I'll cut away here. When I come back, we'll be hooked up to a tube. We'll turn it on and cross our fingers and see if something blows up or see if it works. Well, we're all set up to go. We're ready to read B+. We got anode, neck, yoke, ground, video, power, and remote board. This is a remote board for a U2000, but like I said, you can use a 5000 or a 2000 because the H hold pot is on the board for the 2000 5000, but on the 7475 it's actually on the chassis, so you have to use the right remote board. So we're all set up. Let's find out if it turns on. If it does, what kind of image we get, what our B+ is. If it just goes zap immediately, we'll go from there. But we're ready to go. So we're hoping to see around 117. If not, I have the driver here at the ready to adjust. So, or at the ready to adjust. So let's go ahead and turn this on. Cross our fingers. Count to 3. 1, 2, 3. Nope. Took out the HOT immediately. If you turn this on, you can hear the HOT. Tick, 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 tick. So something is taking out the HOT. The next step is trying to figure out what it is. So here we go. Fun times. Well, I've skipped ahead a bit here and I have the problem solved, but it's not a chassis problem. I'll just say this. The original HOT that was on this was a C3688s. Now, when you try and order these, you can't get these anymore. Well, I get all my stuff from Arcade Parts and Repair, and when you type this in, it supersedes from C3686 to C3688. Now, every one of these chassis, 2000, 5000, 74, 75, I have never had one work that was blowing the C3686 original and put the 3688 in there after it. I have never once ever been able to get one of these to work by putting one of these 88s in place of an 86 when the 86 was blowing. So we checked the board and found nothing wrong with it that would indicate why the HOT would go out. So I replaced the HOT. We saw what I did. I changed the HOT and did inspection. We turned it on and it blew. So there's one down. So I tried a second time. I double checked and double checked and double checked. I found nothing wrong. So I thought, well, okay, maybe that one was bad from stock. So I put another one in, took it out, we're down 2. So then I changed the U701 chip. The U701 chip is part of the horizontal circuit and has been known to cause horizontal issues, and has been known in the past to be the cause of the HOT going out. You know, normally it's 760 or 765, or the polycaps over here, or that diode, or either one of these 2 resistors right here, these 2 right there. There's any number of different things, but it's very rare that U701 will take it out, but it has been known to do that in the past. So I checked all the pins to ground, and the only pin that ran to ground was the one that was supposed to. So none of the pins were shorted. However, I changed it out anyway and put another HOT in, and it did not work. It went out immediately, so now we're down 3. So we're down 3 HOTs have been taken out. So I said, okay, forget it. I've never been able to get one of these 88s to work in place of the 86 when the 86 was being taken out. So I installed one of these beefier, newer, better FJL 6920 ones. I've got a bag of these FJL 6920s. So I put one of those in there, and as you can see, I put a new one in there along with a new insulator. And after putting this in there, check it out. 1, 2, 3. Comes right on. And we're at 118.8. Let's see if I can adjust this down here. I want to reach in here and turn that B plus pot, do it sneakily. And I want to get down to 117. And that's close enough. Perfect. And we have no image because, oh, I forgot to mention, I changed out the flyback, I think in between, I think on this one. Before I changed out U701 and took out this one, I forgot that when I changed out this one, I changed the flyback because if upon closer inspection you can see that it's cracked. It's cracked right there, and it's cracked right there. It's rare for these to crack, but it's cracked right there and it's cracked right there. So I thought, okay, maybe maybe the flyback is the cause. So I changed the flyback. This was the first one we changed. It blew. I changed the flyback for this one and it blew, and I changed U701 for this one and it blew. So I said, okay, forget it. Knowing the history with the 88s versus the 86s, I just said forget it and put one of these in there. And of course it fires right up. Now if there was an actual problem with the chassis, this would get taken out too. If something else was shorted or bad, this would get taken out. There's no doubt. So if this is still intact and operating and running, then there's nothing else bad with the chassis. It's just these, in my opinion, these 88 ones are just junk. I don't understand why they're being referenced to replace the 86s, but I've never been able to install an 88 in place of an 86 and have it work. If there was something wrong with the chassis, it would take out this one too, and it's not. So it's just, those are, in my opinion, just the C3688s are just junk. Don't get them. Get these FJL 6920s because these are compatible with Henrik's Polos and 7000s and 74, 75, 2000, 5000, and I think maybe a bevy of other ones too. So get yourself these. I recommend using these in place of these ones, FJL 6920. So that being said, we're balls on 117, and the new flybacks come with the screen pot turned all the way down. But let's go ahead and start with brightness all the way down, contrast all the way down. Now I got to turn my light off here. Hang on. Okay. And as you can see, no image. If we turn up, the screen pot until we get raster, or, there we go. You can see, let's turn it back down right about there. Okay, brightness, and right there, contrast. Oh, we got an H hold problem. So adjust our H hold, there we go. Glorious. Let's move this back here. And now that we have our image here, we are at 117.3. This tube is also kind of shitty compared to what it should be. H position, I think, is this one here. And yep, there we go. And we'll equidistant it roughly right there. Let's go with height. We have height. And that looks pretty good there. All right, width. Do we have width control? We do. Both sides. Yep. All right, we have a nice square image now. Where's vertical position, you rat bastard? There we go. Okay. Yep, I'd say we're looking good. The tube is a piece of junk. But let's turn our contrast up till we bleed. We're going to be right there. Let's see if our focus is good. If we can get good focus here. Yeah, right there. Well, there you have it. I mean, I did not, these are all original caps still. I have not changed any of these caps. You can still see these are the original caps, untouched. And I do think I have a cap kit for a 2000, but obviously it's working now. I forgot to mention, I set all the color pots to about 25%. Like I say, for these series of chassis, they don't like to be up more than about 25%. Then if you do, they begin to bleed over. So I just set them all by default to 25%. With the drives, I put to halfway. So halfway for the drives, 25 to 30% for the bias, and then you really are normally good to go. So, okay, I think what we'll do now, we're a bit low here, but when the image changes, it should go back up to 117. There you go, 116.8. There you go, 17. So I think now what I'll do is I'll do a full complete cap kit and reflow now that we know that it's working. Nothing was actually wrong with it. It was just the crappy 3688s. And I'll do the full reflow and the cap kit, and we'll come back, see how good it looks, if it looks any better or worse. And we'll call this one repaired. Until, of course, the reflow is going to include all the neckboard rework and everything that's required for that. I mentioned the transistors were actually in good shape, the solder joints and whatnot. So, yeah, also if you hear that high-pitched noise, a lot of times I can push on, oh, see, it's gone already, just from moving the linearity coil. So it needs new caps. But, oh, that's abnormally warm, wow, okay. It's not uncommon for the U2000 to operate a bit hotter, I've noticed. Like the 74, 75, and 5000, they're about lukewarm, or room temperature for the heat sinks, but the U2000 operates a bit hotter than normal sometimes. You know, I can still leave my hand on it, but it's a bit warmer than normal, but it's still okay. So yeah, I think we're working good, and it turned out to be just, I don't know what took out the original HOT. It could have been because this wasn't hooked up. It's very possible. And replacing it with these crappy 3688s versus the 3686 original ones, I can't say. But like I said, if this was bad, if something on here was shorted or bad that took out that HOT, it would absolutely take out that one too, and it's not. It's running perfectly. It's been, you know, I don't know, 10 minutes now. Who knows how long it's been. And it's running fine. So, okay, I'm going to do a full cap kit, reflow, inspection again of stuff, and we'll check it out again at the back end. Make sure it's still working, see how much better it looks, if better at all, and we'll call this one fixed. Okay, all the work is now complete. Full cap kit, full reflow, full inspection. I didn't notice or find anything out of the ordinary. All the caps were good except for one. Now here is something very odd. I've never seen a cap that looks like this. What? Oh, I should say I was incorrect. This cap here in the vertical circuit on the 7475 U5000 is a 1500 microfarad, but is in fact on the U2000 it is in fact a 1000 microfarad. So I was incorrect. I thought all four of these were the 1500, but apparently the U2000 is a 1000, not a 1500. It's just been so long since I've done a U2000. For some reason I've done so many of the other ones in between that I thought they were all 1500, but it turns out that it actually is a 1000. But look at this cap. What is going on here? What is this? I've never seen anything like that. This is just weird. It's like a ceramic flat bottom here that's got a epoxy over it. Anybody ever see something like that before? That's very odd. Anyway, so yeah, none of the caps were leaking. That was the only real anomaly. I didn't find or notice any kind of issues like, oh man, look at that, that's bad, you know. So I got everything redone on the neck, all the solder joints reflowed, and all the caps changed out. Same thing with the main board. You can see here that we've fixed the linearity coil. You can lift the entire chassis off this coil, and we fixed the horizontal coil. You can lift the whole chassis now off of this coil, so it's secure on there. We got the new flyback installed because the original one was cracked. As we saw, it was cracked across here and cracked across there. So I don't know if it even worked or not. We never got a chance to see if it worked, but better safe than sorry because it's cracked, so we changed it. One other thing, I'll do a quick review. We changed out the B+ pot because it had the case missing, or the top adjustable portion. The resistor right next to it, R100? R111, was all jacked up, and I'm sure it probably worked. It's still checked in spec, but we changed that out. We had the blown HOT. We had to go through 3 of them before we just decided to quit messing with these crappy 3866s and go with the FJL series. And then I also removed this capacitor. I don't know what this is for. This capacitor on the bottom that was across the HOT and the across this point and this point here, and you know, it's set like this, and I don't understand really what it's for. Maybe they had horizontal width issues on this with the tube, I don't know, but I checked my other 2 U2000s I have and they don't have this, so I don't know what's going on with that, why it's there, but it worked perfectly fine. We checked it out with this removed. So previous to this, just a few moments ago, when you saw it operating, this was actually already removed. I think I may have forgotten to mention that, but in my attempt to try and figure out why the HOT was blowing, on the final attempt after changing out the U701 chip up here, I went ahead and changed this out as well before powering it up, thinking maybe this has something to do with it. So I powered it up without this installed, and it still died. And then I put the FJL series in there and it fired right up. And when you saw it operating, that was with this removed. So I'm still going to include this, send it back to the owner, and if they need to reinstall it for their tube setup, they can. But I don't think it's supposed to be there. I'm not sure what it does. It's not supposed to be there. So I'm going to include it in the bag of stuff here to send back to the owner. And if it needs to be reinstalled, he can reinstall it, or I can show him how, no big deal. But for now, I'm not going to leave it on there because I don't know what it's supposed to be doing, and my other 2 U2000s don't have this. So it's not going to hurt it to be off. And then of course we have all the bad caps and whatnot are all up here off camera. So all right, well, let's hook it up. Make sure I didn't put something in backwards. Make sure nothing catastrophic goes kaboom. Make sure it still works. Make sure our image still looks good, and if it looks better, hey, that's a bonus. And then we'll let it run for a while and call it a successful repair, and we'll see how the rest of these go. So let's get on the tube, test it out, and see what happens. Okay, final testing, here we come. We got everything hooked up, anode neck, yoke, ground, power, video, remote. And it's always a good idea to recheck your B+ after doing a cap kit and everything like this, just to make sure that it doesn't need to be readjusted. So we're hooked up, ready to test B+, and again, I don't think I showed it last time, but it hooks up right there. There's a test point right there, TP202 B+, that's where it is on the U2000. And you can see I clearly have not turned it on yet, or we would be reading voltage. So yeah, let's turn it on, make sure, and I didn't put a cap in backwards, make sure nothing blows up. And we're still at 117 and it works, and see how it goes. So let's do it. 1, 2, 3. Ah, it's a bit lower. Should climb up. Hey, there we go, 117. Fantastic. And do we have an image? It's slowly creeping in there. Did I mess with the focus? Why is that so out of focus now? That's weird. Let's see if I can adjust that. Hey, there we go. That was weird. Alright. Each position. Right there-ish. This tube is just absolute junk. But hey, there we go. This tube is so bad that in the middle it's in focus, but around the outside it's extremely out of focus. You can see how out of focus that is, but if we go in the middle, it's super sharp and crisp. So this is a bad tube. The outside is out of focus, but the middle is good. So I've already tried to rejuvenate it. It just does not take. So this is I got two tubes that are like this. But if we readjust, let's go brightness down, contrast down, and then let's turn up our flyback until we get an image and or raster. Okay, see, we got something there. Let's turn it down till that goes away. Have to wait for this to come back up. Right there. Okay, contrast needs to be, oh, right there. Brightness. Yeah, that's not bad. There you go. So yeah, we can call this repaired. We're sitting pretty at 117.0. You saw there was just 117.5 a moment ago, so our B plus is perfect. We're all operational, we're all working. It's good to go. So all that trouble and headache was just the real crappy C3688. I don't understand why the 3688 it's supposed to be a direct replacement for the 3686, but as we see, they're just junk. You put the FJL in there and it works perfectly. So like I said, if there was something wrong with this chassis that was shorted that would take out the HOT, it would clearly take out this one too, and it's not. I think that's about the 4th time I've said that, but I just kind of get the point across that the 3688s, don't mess with them, don't bother with those, just get the FJL series and call it a day. So we can now mark this as fixed, and we'll move on to the next series, or I guess the next one in the line, I should say. And yep, working great. I'll let it burn in for about 3 or 4 hours, like I always do, just to make sure we don't lose a color or nothing happens, and then we'll put it on the done pile and pick up the next one on the need to do pile. So thanks for watching. Very interesting trek, or a very interesting journey on this one. There's the flyback and the rest of all the old bad parts here that I always send back with the chassis to the owner. So stay tuned for the next one in the series, and we'll see if that one goes any better or any worse, or how it goes in general. So stay tuned, and thanks for watching. We'll see you then.